Viewers, welcome to this video on NS3. In previous video, we have discussed about the mobility models in NS3. Also, we have explored about the constant position mobility model in NS3, which is used when suppose we want that our node should occupy the stationary positions and they do not have generally the movement. So, in this video, we will continue from there. We will explore about the other mobility models in NS3 and we will experiment with them. So, without wasting much time, let's get started. So in today's video, we are exploring about the random movements in simulations. So there is a way by which we can provide random movements to our nodes in simulation using already available mobility modules. So let's say we want that our nodes should do random movements while the simulation is doing in the NetAnim or the simulation is running in the NetAnim. So namely they are like random walk mobility model and random waypoint mobility model. Both are used to simulate random movements for the nodes in a NetAnim, right? So basically when suppose you want to move nodes randomly within the predefined area. So let me just open the code of the last video that we have seen in the last video. So we have set the mobility model in previous video to constant position mobility model. So now here what we can write random walk mobility model when suppose we want our nodes to move the randomly within the predefined area. Then there is a random walk mobility model which is useful when suppose you want to simulate random movements but you don't want that, or you can say but you want that your node should pause before selecting or moving to the next random point. So then in that case you can go with the random waypoint mobility model. So let's explore about them. So this is the code that we have seen in the last video, right? So let's just close it. So this is the new code that we are exploring today. So I have changed the topology a little bit. In previous video we have used the my first, or you can say the first.cc file. We have renamed it to my first.cc file, and basically we have simulated the constant position mobility model inside the first.cc file. So now I have modified a topology. I have created 4 nodes, or the topology with the 4 nodes, and I have created a CSMA link. So basically that's a common bus topology with 4 nodes, right? And basically you might aware about the codes, and just we need to explore about the mobility model, right? So simulating the topology with the 4 nodes for this CSMA topology, or what you can say the common bus topology, now you might be aware about the things because as you have following my playlist, so you may have watched those videos where I have explained about the CSMA helper and all that stuff, right? So now let's focus on the main topic. So this code you might be aware about. So that's a mobility module, and we have used the list position allocator to allocate the positions, right? And these are basically the 4 nodes. So I have included 4 different positions, right? And then in the mobility module, in the mobility helper, I have set the position allocator as P, right? And now just for sake of knowledge, so this is like a random waypoint mobility model, right? So as I have told you that random waypoint mobility that is used when suppose you want that your node should move randomly, but it should pause for some time before going to the next position, right? So let's just comment out this for now. Let's just first explore about this. Let me just comment it out. So yeah, and I can just put this line over here. So as you can see, let's just first explore about the random walk mobility model. So as you can see, when suppose we want that our node should occupy the random movement and it should be continuous, right? So it should be constant randomized change. So in that case we can use this random walk 2D mobility model, right? and with that we need to pass one more thing, which is bounds. Bounds means what you can say, the area in which your position should move, right? So basically you are bounding the node with that area, that your node should what you can say, choose the position between in between, or what you can say, inside that area only, right? So your node will move randomly, but it will be inside these bounds, right? So basically that's a rectangle value. And as you might be aware about, the rectangle value should, it is like that x position, then the y position, and then the x position, sorry, the mean x position, the max x position, the mean y, and max y, right? So that's how rectangular area works, right? So that's how you need to pass, but take care that while you pass the rectangle value, it should be included within rectangle value. Then I have used install method for each and every node, right? So basically node with index 1, 2 and 3 will be allocated to this random walk mobility model, and then node 0, it is what you can say, it is like configured with the constant position mobility model, right? So in last video what we have seen, that we can install position at the same time on all the nodes, right? But let's suppose we want that individual nodes should have individual mobility model. So you can do this by this kind of thing, right? So basically you set mobility model, then you install, then you set another mobility module, and then you can install. So we'll compare that what is the difference between constant position mobility model and random walk 2D mobility model. So basically the constant position, that means the node should not have any movement, it is stationary, and here they will be moving randomly within these bounds. So let's save this file and let's run, and we'll open a file.xml inside NetAnim, right? So we are inside ns3 root folder, and this file is inside scratch, so you can see. So now let's just type command /ns3 run my first. Let me just see, yeah, that's the name, I guess. So let's just wait while this file is executing. Yeah, the file is executed successfully, right? So you can see the output, right? And now let's just open NetAnim like this. So now we can open that file.xml, which is inside ns3 root folder, file.xml. So you can see the nodes are in the correct position. Basically that's because we have used this glitch position allocator. So now let's just play the simulation. So you can see the behavior, that nodes are randomly moving inside the area, right? So that is what you can say, the constant change is, you can see over here, right? And that's the packet. So basically that's a CSMA, or you can say the common bus channel. That's why these packets are coming out of node 3 and going inside all the nodes, right? And again you can see the constant changes in 1, 2 and 3 nodes, but the node with index 0 is constantly at the same position, at the initial position, what you can say, right? And that's the second packet, and actually you can observe the things, right? So I'm pausing the animation. Hopefully you have seen the significant change between constant position and the random walk 2D mobility model, right? So that's the random walk mobility module, right? Now let's say we want that our node, you have seen that they are moving constantly in the random position, but we want that it should take pause, right? So we can use this mobility module. So now let's explore this mobility module, which is random waypoint mobility module, right? So I'm taking this node with index 1, not node with, let's say node with index 2. Just we paste it over here. So you can set random waypoint mobility module by this, and with that you need to pass several things. The first is the speed at which the position should change. Then there is a pause, that before moving to the next position, what is the time for which, what is the amount of time for which it should wait in the current position, right? So let's say it should wait for 2 seconds before moving to the next position, and it should follow the speed of 1. Then you should also pass the position allocator, which is pointer value to this p, right? So that's the basic setup of random waypoint mobility module, and if you want to install, then you can use the install method. So we have basically installed inside the 2, let's say we can include inside the 1. So node with index 1 and 2 are having random waypoint mobility module. Then node with index 3 is having random walk mobility module, and node with index 0 is having constant position mobility module. So that's the thing, right? Now let me simulate. So before simulating, let me clear the screen and let's run the file again. So as you can see, the file has been executed successfully, and output is also you can see over here. So now let's go inside the NetAnim. Let us reload this file, and as you can see, the position are already configured. So you can see node 3 is moving randomly, node 0 is stationary, and you can see after 2 seconds, the node with index 1 and 2 move to the random position, which was I think 0 0, which is I think 0 0, right? You can see also it is moving randomly, and you can see that node 0 is at constant position. It is not changing the position of its own, right? So that's because it is having constant position mobility module, right? You can observe the animation, by the way. You can do this inside your machine, and you can experiment with it, right? So I'm pausing this because there are 5 packets, and let's just, yeah. So that's the thing. So this is the code. I'll share this code. I'll ping the GitHub repository link inside the video, or you can say inside the description box. You can explore the code, you can understand the code, or you can take a snapshot. And yeah, that's it for today's video. We have explored the random movements, that how we can simulate the random movements in the NetAnim. And that's it for today's video. We'll meet in the next video. Till then, keep learning and keep exploring.